My name is Sebastian and CISO. I did this assignment by myself, um, and I originally tried doing it in C++, but after about a day I realized it was going to be too much work, and it might be easier just to do things here in Python. So this is the language I'm using, is Python. Up above here you can see the topology files that I'll be using with my servers. So each server has a different topology file set up. And yeah, if we dive into the code here, we can see I have a bunch of functions here that are helping other functions and whatnot. This first one is update cost to neighbors. It updates cost to neighbors, exactly what it's saying. This one closes all threads. This one updates the user table upon receiving a message. This creates the message to be sent out to neighbors. Do something is the function that will be sending out messages to the neighbors at a given interval, which is given through the command line. This helps the other one, so this is sending neighbors. This connects to the neighbors, so first I'll get sockets and then I'll connect those sockets. This helps find the cost, so I can find the cost to my neighbors through that function. This gets my neighbors' ports upon initialization. This sets up my neighbor sockets, so I'm able to send them messages. This gets host port, so the port I'm on for the host. And then the main function here is update routing table, which probably could have been done better, but I'm not really too familiar with Python, so this was kind of a big learning project for me. This is my first time really doing Python, especially socket programming. So, and compared to C, it's actually been really nice, but I'm sure there's some better ways to go about things. So yeah, it's a bunch of conditionals. Sorry for some of these prints. It was just helping me figure out exactly what's going on. It's hard to just read the numbers without seeing like a visual. And so yeah, else if. This helps me parse messages. So with the incoming message, I'll parse that and then be able to do stuff through that command. This loads routing table upon initialization. This is for displaying the routing table. This is to disable the connection and to handle clients. Handle client is what is used to receive messages, and so it handles the messages received from the client. This gets my cost to my neighbors, which is helped with the updating the routing table. And then we have our main function. This command here will get the interval. This opens the topology file. And then all this stuff will read the topology file and set up everything that needs to be set up, and then I will start listening on the server. And so this is my thread here, so I can send messages to my neighbors at that given interval. And then this is my while loop. And so within my while loop, this section here is for incoming messages from my neighbors, and this else section here is for user input. So when user types these commands, we will do certain things based on those commands. And that's pretty much it for the code part. So if I go in here to the demo, I can type in Python distance vector algo, and you can see I'm giving it the topology file with the correct server and the interval time. I'm using 10 because for demo purposes it seemed better. I probably could change some on some of these actually. First, let me just show you the display command. So you can see this is a display. So I'm not connected yet to my neighbors. By typing connect, I am now sending my routing table to neighbors. So this table here previously didn't know about 4. So now that one is sending information, it knows its distance to 4. So if I go display, you can see now it knows about 4, and the distance to 4 is 12 because I'm doing 7 plus 5, because 1 to 4 is 5, and then 2 to 1 is 7, giving me 12. I can also connect the bottom one here, or any of these actually. So let me connect this one. Just wait here. We'll connect here. So now we are receiving messages from 1 and server 3. If I hit display again, let me just wait here just a second. You can see now that this has changed because server 3 has found a shorter route, which now 2 is taking that to get to 4 now, which is 5. If I want to update certain things, I can go update, and I will update 3 to 4 equals 1. And so you see update is success, and now if I do display, you can see now the distance is shortened. Now it's 4 because this used to be 2, and now it is 1 through the update command. I can also show packets. So this has received 17 packets. This one has received 6. This one has received 12 as well, and this one has received 19. I can also connect this guy. Oh. Yeah. So now this is receiving messages. So this is connected, this is connected, this is connected, and now I will connect this one. And so now everybody's kind of talking within the given interval of 10. Some of the other commands that I need to demo are, step. So I can step, right? I can send a message without the given interval, so boom. So that everybody received a message from 1. I can step down here. Everybody's received a message from 3. And then I'll wait again. And now I'm sending from step from 4. So you can see step, and you can still see display. And then I can disable servers. So if I want to, let's just say disable 2. So it cuts the server 2 off, and so now it's only receiving messages from 3. And I can also crash. I'm horrible at doing these videos. I can also crash. So this will crash all my sending from all my servers. So if I type in crash, so now we are not receiving anything from 1. We're only receiving things now from 2 and 4. If I crash this, so now this is just receiving from 4. So now 1 is just getting from 4. And if I crash this, and now we are all good. And that is the end of my demo. Oh, wait. It's still receiving a message from 3. So let me crash this one. Oh, yeah. So now we are crashed.